Welcome to the Trend Detection podcast, powered by Siemens, and now your host, Gagan Sangha. Welcome to the Trend Detection podcast, powered by Siemens, and now your host, Gagan Sangha. In today's episode, we'll dive into how the automotive manufacturer has achieved its success, the technologies they've implemented, and what other manufacturers can learn from their journey. To help us dig deeper into this success story, I'm joined by some fantastic guests who have valuable insights into the processes and technologies that have driven this plant's success. Jan and Peter, thank you for joining me on today's episode. We're looking forward to hearing your insights on what has made the plant a standout in the automotive industry. Please take a moment to introduce yourselves to our audience.
Yeah, hello folks, Peter O'Hara. I am a customer success manager here at Siemens, working with Senseye Predictive Maintenance. I've been with Senseye for just over 7 years, and my aim in life is to help our customers to use the application, add more users, celebrate any wins, add more machines, and slowly take over their entire facility, going site to site until everything the customer does is monitored by Senseye Predictive Maintenance.
My name is Jan Trnovec. I'm a technician, a specialist in Cyprin, which is a daughter company of Siemens. We provide maintenance and engineering services to our customers, mainly in automotive sector. My work is mainly to reduce the downtimes, to reduce the price of the maintenance, and to achieve that our customer can make as many products as he can.
Perfect. Thank you both for your introductions, and really interested in this topic. So looking forward to hearing your insights into the automotive industry and, key successes around some of the asset types. So what I wanted to do was to kick off this podcast and ask a first question around the asset type. So I understand that asset type is a high pressure pump injecting foam into car bodies for soundproofing. So if you could just provide a bit more background just for our audience so they can understand, that would be great.
Yeah, I'll start off just because I can do the high level, and Jan obviously knows his equipment way better than me. But it is a really interesting use case for us, because I believe this was the first time we've monitored a pump injecting foam into the car body for soundproofing. And for one area, when we are talking to potentially new customers, one of their first questions is always, have you monitored this particular machine in this particular environment before? And I would always like to say, no, but that's not necessarily important, unless, of course, we have, because we monitor many thousands of machines across many thousands, not many thousands, hundreds of customers. And the main thing is we use the same algorithms to monitor data that means something to the condition of the machine. And those algorithms are self-learning. And so it's about feeding them with the correct data that will tell the application something about the condition of the machine, and ideally removing the process that the machine is undergoing. And that can be a little bit tricky, but getting something about the condition of the machine. So in this case, we're looking at a process that has 3 stages to it. We have a pumping mode, a circulation mode, and then a pressurization stage. And for the circulation, we are monitoring flow rate, pressure, the RPM of the pump, and temperature. And then when we get to the pressurization stage, we take the time to get to half pressure and the time to get to full pressure. And one of the beauties of this application is that Jan chose the data himself and decided what to feed into Senseye Predictive Maintenance, and then very quickly within the deployment, we had this first success that we are talking about. So perhaps I should hand over to Jan to just tell me a few more things about this injection pump.
Yeah, as Peter already said, there are like high pressure pumps which are feeding or pressurizing the medium to mediums, which are mixed together in jets and then create the foam. I think the most important thing in this success was that we had the right data, which described the machine, the failure mode of the machine, because we knew that the pumps go wrong, and these breakdowns cost us or the customer some time to replace the pump during production time and so on. And so therefore we looked at the pumps closely and found out that you can actually see the washing out of the pump in the way how the pump is building the pressure, so in the pressurization stage. And in this pressurization stage, where the circulation valve closed and the pump starts to build pressure, we can see that if the pressure isn't rising linearly but slows down as the pressure rises, then we know that the pump starts to wash out, and which is then followed by a breakdown. So we simply started to monitor via Senseye Predictive Maintenance the time, as Peter said, needed to reach half of the set point, and time needed to go from half of the set point to the set point itself. These two times we called half time and full time, and we programmed all the logic inside in the PLC to get these two times regularly for each pressurization stage. Then we connect it to the Senseye, and voila, after about 2 months, we get a warning from Senseye that the time is changed. The full time was changed on one pump, and we could see that really the curvature of the rising of the pressure was changed, and we could see that the pump is going to be wrong, like it's going to break down. What we didn't know that how much time we actually have. So we saw that the pump is changing, but we didn't know how long does it take to how much time we have to the actual breakdown. So in one case we actually leave it, and then we also knew the exact time when the pump will go wrong, and when the pump will break down, and now we like 100% know or 99% know where is the limit we can go to use the pump as much as possible. And that's actually interesting because we get a warning like a month and a half before the actual breakdown. That's quite nice. Like you have a month to plan the replacing the place of the pump. That was really nice.
And then, so you didn't add any more sensors to the pumps. This is just harvesting data that exists. Is that correct?
Yes, of course. Yeah. That was also really nice that we didn't have to change something on the machine to add sensors and so on. We just used all the data we already had. We used the data from frequency converters about the speed of the pump. We used the pressures which are being monitored also for the technology purposes of the machine. for the regulation and so on.
Mm-hmm.
So we don't have to add anything. We just collect it or summarize the data which we already had in the PLC, and then we write the files in the visualization and then send it to Senseye.
And so what process did you go through to go from, obviously you had some data, but then you'd have to look at it at fairly high resolution to choose what to send to Senseye? And then, so how did you go through that process?
Yeah, we simply used an PLC analyzer to see in high resolution the data, where we looked at the behaving schemes of the machine, how the pressure rises, how it fall down, how the system works simply. We tried to understand what's going under the skin of the machine, and then we found out that you can simply we managed to find out the simplest way how to get the important data, because that's I think from my point of view it's the most important thing to feed the right data.
Correct.
Because
Yeah.
if you have only some data, the Sensei is a perfect tool, but it isn't some wizard inside with a glass sphere telling you now it will break. It calculates. Yeah.
And we often try to guide our customers through a process of having the correct people in the room at the early stage of a deployment, so they know maybe somebody who has IT/OT type experience who is able to get the data, but also we'll have a maintainer there who will be able to say what failure modes are important to the customers, and also some management to decide which machines are important, etc. It sounds to me that we have the perfect person on the project, because you can analyze the data, you have the skills to interact with the PLCs, you have the skills, the analytic skills to look at the data to decide what is important for these failure modes, and then to pull that out. So this was a beautiful deployment, but if we could scale YANs and put them in every factory, I think we would have a much easier life.
Yeah, but it wasn't just me. Like I have had a colleagues that helped me. Of course, I had in particular one colleague, a technician, which knew the machine really well, and he was able to tell me some insight. Where can I look?
Mhm.
And then when I looked, I found it. Yeah,
Mhm.
that's always the thing that you need colleagues, you need the experience of probably more years. You need also the experience of the team behind Sensei, of course,
Mhm.
which you can tell, who can tell you what is the Sensei able to do, how you can monitor this and this, and also. As you mentioned, you didn't had any experience with, for example, foaming machine or this type of machinery.
Mhm.
But when I reached to you with particular types of breakdowns and what type of data I have,
Mhm.
you helped me on the other side. Okay, we can extract it in this and this way, so we can monitor it back then and process it at the Sensei side.
Yeah.
So that's always it's not one person.
I will agree it's not one person, but it's the skills you need to make a successful project involve
Yeah,
knowing the failure modes that you want to capture, but then having the ability to get the data. Now, sometimes that is pulling it from a PLC. Sometimes it's I need to add an additional sensor here and having that bit of experience as well. But yeah, it's it's nice to see a Siemens colleague, fully embracing the process of getting good condition monitoring data into the application and then letting the application kind of run with it. And then I think with early day success in a project, we always need a couple of pieces of luck. So one is an early machine failure. Obviously, you never want the customers to have machine failures, but when you look at the likelihood of a project succeeding, you need to have machines, enough of them, so the chances of one of them failing early on, within the first couple of months, that certainly helps. Because if everything runs as normal for quite a while, people are like, yeah, well, why are we monitoring this? And then as soon as things start to happen, then you can help people to see that actually, yeah, this is good. This could be successful, and then you get them to think, well, where else do we have a problem? Where else can I harvest data, or where could I put some sensors, and then pull that equipment into the application as well.
Yeah, exactly. Like it doesn't make sense to monitor a perfectly well and working machine which doesn't have any breakdowns. Like you can monitor it for years and nothing happens. Like that's also a important thing, to monitor things which do break down and which are also important, because every like in every facility, in every plant, there are machines which aren't important and they do break down but you just somehow know you do not care, like they are not important. And then there are machines which are really important because they stop the line, for example. And these are the important ones. These are the bottlenecks which you have to analyze also from the management level, and these needs to be inspected properly, and if possible, then also monitored via possible solutions of Senseye, which is one of them. And from my point of view, one of the best ones.
That was really useful information just to understand background around this asset type. And I just wanted to move into the next question, just around, what role does the foam injection pump play in the automotive process?
Yeah, it's used for dampening noises, or noise cancellation simply. So the foam is injected in pillars of the vehicle, for example, into A pillar or B pillar, in the pillars above of the axles and so on, to cancel noise. So, and one has to mention also that not every vehicle does have the pillars formed. It's not like the standard feature. So that's also possibly the reason why Senseye hadn't yet the experience with such a machinery, because it's not absolutely common machine in automotive world. But some customers use it, and what I see, it's used more and more often. Exactly because of noise cancellation. It's quite a good way for noise cancelling. And as the technology evolves, it will be probably used more and more.
That sounds good. So one of the questions we had was, how did Senseye Predictive Maintenance detect the trend, and how reliable are the alerts? So what I would say, I think I'm probably repeating myself here, but we use a fleet of algorithms that learn the normal behavior for a machine. And I think that this is different to a lot of other products out there. So we don't have people behind the scenes making models for all the different machine types that we monitor. So the early days learning is all unsupervised. And what I found interesting in this case is that the data for, I was looking at this yesterday, the day before, the data for this machine, it stayed stable for about 4 days. And then it started to trend up. And then, as you said, Senseye alerted the user after about a month that this data was trending up. But I thought that was quite interesting. People often ask me, how long is the learning process? And the short answer is it depends on the type of algorithm alert that we're using, but usually we quote about 48 hours. And I found it interesting that, like I say, with this, I could see the data was nice and stable for the first 4 days and then just slowly started to trend up. So I thought that was quite interesting. And then one of the other ones, sorry, Gagan, if I'm stealing your thunder with this one, is the role of the co-pilot. So we haven't really mentioned that yet, but with the use of Copilot in industrial applications now, the Copilot did spot this failure mode. I wondered what you thought of that.
Yeah, thanks to the expertise we have done in the first stage, the Copilot actually didn't told me anything which I haven't already knew.
Mm-hmm.
But the thing is that after replacing the pump and so on, we insert the input the all the necessary data into Senseye, and then on the next case, the Copilot already pointed out that it's probably a pump which has to be replaced,
Mm-hmm.
which was also the right answer. So whenever this system will be used by someone who doesn't have as much experience as, for example, I have,
Mm-hmm.
the Copilot can direct him what to do.
Yeah.
And I think that's a really, really, really good thing, that it can use the information which is put it in, and to show it to the next person who doesn't have to have such deep level of the knowledge of the machine.
Yeah, I agree with that, Jan. I just wanted to highlight, I think that's one of the key benefits with the Copilot. It's designed to take that knowledge, and you don't necessarily need to have a high level, amount of knowledge to understand. So it helps to support and just break that information down. So, sorry, just wanted to jump in.
Yeah, especially when we're scaling. This is the thing. And so I've been in this industry for 7 years with Senseye Predictive Maintenance, but early days of the project, you are working with knowledgeable people about their machines, and then you go to scale, and then sometimes you go to a different plant or a different site, and that knowledge can be hard to replicate. And so the fact that the co-pilot will tell you exactly what's going on, but also you have the ability to ask it the silly questions, because we have seen in other projects in the past where the project gets moved on to people who are perhaps not as data literate and perhaps don't understand what this data means for their machines as much as the original people on the project. So it's really nice that you can interrogate it, you can ask it questions. As I often say, it takes my role, customer success management, it takes me a while to build rapport with people. And I know I've cracked it when they turned around to me and say, I don't understand what this means. But people will ask the co-pilot that sort of question way sooner because people don't mind asking the co-pilot the questions that they really want to ask. And sometimes they just say, I was just testing it to see if it knows. And it's like, yeah, that's what it's there for. Just ask it away. What does this mean? Why is it doing that? I think that's a really beautiful step forward, and it's great to see it out in industry. And yeah, nice and quick in this case as well.
Yeah, I was going to say as well, Peter, just touching on that point, I think we had a discussion maybe a couple of weeks ago, but around the co-pilot, people generally seem to be more open to
Mhm.
asking questions. And like I said, it's so intuitive, like it can give you that information without talking to, a human as such, if that makes sense. If you need the answers there and then, it's very quick. So definitely helps with efficiency.
And as Jan said, he closed the case, and then the next time the co-pilot sees something, it's feeding back the words that Jan has used to the users, and so you spread that knowledge throughout the organization because the co-pilot will tell other people, and it's a very powerful tool for upskilling the users and the workforce and sharing knowledge.
So moving on to the next question, I'm really interested to understand how critical was the 40-day early warning in avoiding downtime?
Normally, we need like mm, only days to warn us because when we get a warning during the week, we we always are able to manage the replace or the repair during the weekend when the line stops. The thing is that if you have such a long time period, you are able to manage it. Not only that you repair it as the machine, but you get into the stage that you can manage how many stocks do you have. Because all the things you need to replace or the spare parts you want to have to replace at some breakdown and so on in such a machinery, you need a spare part for it, and you have to manage this spare part, and you have to decide how many parts do I want in my warehouse.
Mm-hmm.
And that's also in a cost way. Like you can choose, okay, we have 8 high pressure pumps, and we would like to have 8 spare high pressure pumps in our warehouse. But it would be really high cost of the warehouse, which doesn't make sense, of course. So if you get warning like month before the actual breakdown, you are able to lower down the spare parts costs in a way that you don't need, for example, 2 or 3 spare pumps. You
Mm-hmm.
just need 1 or 2. Like if one goes wrong, you send it away to the repair, and one rests in the warehouse for some immediate repair or whatever you need in case something really goes bad. But if you use it, then you have time to contact the manufacturer. Okay, I don't have any spare parts in more. I just got a warning that in 1 month my pump do breaks down, do break down. So can you please send me? You have 2 weeks, and that's a really good thing because you can then manage the warehouse really good.
Yeah, No, that's great, Jan. Really great to hear because it just reinforces the whole reduction of costs, improving efficiency,
Mm.
having that information sooner rather than later just helps to plan accordingly. So at least you know what actions need to be taken.
Yeah. There's
Um,
also, if you know that you have a month to replace a part, then you can also perhaps plan that in so it's not necessarily during the overtime period, so your labor costs can be reduced as well as your inventory costs. And we know that a large proportion of a part's carbon footprint comes from the transportation of it. So if you are expediting a part because of a failure, then that carbon footprint is about twice what it is normally. So having uh, a long lead time to knowing when you have to maintain things is obviously much better for many parts of the organization for the customer.
Yeah.
yeah, definitely. And I know we've highlighted maybe some of the key benefits as such, but it would be really great just to understand in terms of this success story if there's any main benefits which have been achieved, and also on the flip side, just to see if there were any unexpected challenges during this process.
Yeah, but the benefits are clear. I think the downsides, I actually can't think of any. Like we just did things which helped the machine goes a little bit better than before. Like I don't see any downsides to it. Uh, regarding some troubles or uh, how was the word? Sorry, used
Challenges or
challenges. Yeah, of course. Thank you. Regarding challenges, uh, the challenge was to get to the data, to get the data into Senseye, not in terms or in terms of infrastructure, because the machinery is 20 years old or 15 years old approximately. So it doesn't have the proper connection, and also the legal basis of sending data outside of the plant was always a problem to get all to get to um, go with the data all with all through these firewalls and so on. So that's one thing which is the main challenge to send the data away, and that's always a problem because the IT infrastructure is sometimes not um, as how to say it.
There's often challenges around data security and
Yeah,
what tools are available to harness the data, capture it, and to transmit it as well. Obviously, the beauty of working for a company like Siemens is there are a number of different technologies that allow the customer to send data to the cloud and to store it effectively. But we always have to have agreement from the customer's IT department about that cybersecurity, and that can often slow down the initial process with a customer because, of course, everybody wants to make absolutely sure that their data is secure and that they're not leaving any intellectual property out there that could be captured by anybody else. So we have plenty of technical data sheets and security questionnaires and all of that sort of thing that we can share with potential customers.
Yeah, that's exactly the thing that in our case we don't even share like the technical data or technological data of the machinery. We don't need any data of the product
Yeah.
itself. We just monitor the physical data of the machinery, not the technical data, but not technological data.
Mhm. So we know the pressure that the pump is under at any one given moment, but we have no idea what car model it is or anything like
Yeah,
that.
yeah, exactly. Yeah.
Yeah. And Pete, from just from your perspective, how does this predictive maintenance approach scale to other equipment?
Well, I would suggest easily. We've with our other automotive customers, we've often started in one shop on some critical pieces of equipment, and then we've just scaled and scaled and scaled. And now, when you look, we have many thousands of machines across different sites. We have all sorts of different types of machinery. Will be in the casting house at the beginning of the process. Will be in the machine shop. Will be in the body shop as the cars are. Well, forgot stamping. Will be in the press shop. So we go through every part of the process, right through to from the paint shop. We'll be monitoring the machines that's scrubbing the nasty chemicals out of the air of the paint shop before releasing that to the environment. So we can monitor anything. The one thing we need is data that means something about the condition of the machine, and ideally people to understand what that data means to them. So we can take some really nasty data if the customer is happy to know, okay, I don't want to know if it spikes all the time, but if it's spiking 20 times over the last 40, then I want to know. Or if it's, if this data's dropping, I don't care about it. But if it goes really low, then I really want to know. So as long as they can tell us what they want to see from the data, we can make a few little tweaks and get the system to tell them what it is they've asked to know, and then scale. So we have some some customers will have one or two sort of critical machine types, and then many less critical machine types. And we have things like temperature of electronic cabinets. We'll have hundreds of those, and they just run weeks, months, never really changes. You have little fluctuations, but then as soon as somebody fixes the AC and forgets to turn it back on, all the cabinets heat up, and Senseye will go, "Whoa, guys, you've got a problem over here." So it's not necessarily about the equipment that you need to look at every week, but the equipment that will be important to you if it stops working.
Yeah, of course. And that just reinforces, from a Senseye predictive maintenance perspective, that there is potential to essentially monitor any type of asset
Mm-hmm.
within that industry, which is really interesting and really good to know. Um, what lessons can be applied to similar future issues?
Uh, well, I think customers should do what Jan did, really. So understand why you want to monitor a particular asset. That's always important. Don't just monitor something because it has data, because chances are that data won't necessarily tell you something about the condition of the machine. So we always have to look at the reason you're monitoring this machine and the reasons why. Now, that can be preventing downtime, it could be preventing over maintenance, it could be because of what we were saying about the stock of equipment, that sort of thing. So, know why you're monitoring this particular machine, look at the data that you're monitoring, understand what that data means to you to highlight those particular issues. I would always want customers to start at a reasonable scale because, as I say in other podcasts, most customers intervene in between, say, 2 and 12% of their equipment per year. So if you choose a small sample of equipment and say, right, we're going to run a 3-month proof of concept on these 5-10 motors, then what's the likelihood of something failing in that time? And so you're not giving yourself or the project a great possibility of success, because we want to try and take chance out of this. So I would suggest a reasonable scale, so that you will see some issues with the machines. Ideally, you start with a more simple machine type and that you can get data from, or you start with a machine where you can add sensors. So there are plenty of vibration sensors and that sort of thing. We have plenty of customers who monitor things with just current monitoring, and particularly since the Senseye Predictive Maintenance has become part of Siemens, we are getting a lot more information from Siemens drives and PLCs, and being able to harvest that is really good. And we have lots of colleagues who can help us with non-Siemens PLCs. So if you've got PLCs out there, you can get data to Senseye, and you can start your journey. Start and then just never stop. Just keep adding machines. That's all I want you to do.
Yeah, of course. I mean, it helps, doesn't it, in terms of just from a machine perspective, asset perspective, it's about fixing the issues. And I feel when it does come to a lot of these different asset types, it's having that education and knowledge to understand what's going on with your machines.
Mm-hmm.
And that's where, Senseye Predictive Maintenance really helps with that process. And Jan, just touching on what you mentioned before around this collective approach, when it does come to these type of projects, it's all of these key stakeholders who come together to support the process and assist with, the success cases of particular assets within this industry.
Mm-hmm.
So just to wrap this discussion up, just wanted to understand, from a Siemens perspective, Siemens provides solutions to many other industries.
Mm-hmm.
And it'd be really good just to understand, just for the benefit of our audience, what those solutions are and how we can support when it comes to those industries.
Yeah, so obviously, I mean, Siemens supply a lot of industrial equipment, so a lot of the PLCs, a lot of the drives, etc., a lot of the hardware, and they are now linking that through various different technologies, whether it's Brownfield Connect, Industrial Edge, Insights Hub, etc., to get the data that a product like Senseye Predictive Maintenance needs to work. So they are enabling us as a software to get the data from our customers. So that's I think the main area where now we are part of Siemens. That's really, really useful. And we support customers in many different industries. So if we focus on, with the automotive, we've got customers who will be mining the iron ore, etc., that will then go, and we have customers who are smelting and rolling and producing the metal, and then we have the providers of parts for the car industry, and then obviously the cars out the end, and then for the customers of those who buy the cars, we are monitoring pet food, we're monitoring ice cream manufacturing, candies, different household products and things like that. So it doesn't really stop. We are not limited to any particular industries, any particular sectors. We have our focus, but from a Siemens point of view, I would say to anybody who is an account manager out there, please talk to your customers. If they have a problem, that can be solved by predictive maintenance, then let's get talking, because we would love to help them. They must have data out there. If they don't have data out there, Siemens provides the equipment to get that data. And if they have machines and they can't get the data from it, Siemens provide people who can pull that data. We have partners who will provide you with certain sensing solutions. Siemens have certain sensing solutions. So the world is our oyster. And we are determined to start monitoring every machine out there.
That's what we want to hear. Jan, from your perspective, is there anything that you wanted to add just as we wrap this episode up?
I don't know. Peter stole all my words.
Wow, sorry. Well, I really do appreciate you joining us, Jan, and I've loved interacting with you on this project. And man, if I could clone you throughout Siemens, I would have you in every facility, because the way you have helped with this project is just fantastic. So I really appreciate you.
Thank you. I really appreciate the help from you, Peter, and also particular from Jack Dutton. It was
Definitely.
really helpful.
Yeah, we all love Jack.
Yeah, definitely do. He's a great asset, isn't he? He's amazing at what he does. But just wanted to say a big thank you to both of you for joining me. Really great, valuable insights into the processes and technology that have driven this plant success. So it's been a really great discussion. And yeah, thank you once again.
Thanks for hosting.
Thank you.
You're welcome. Please like and subscribe to all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.